Hi guys, so let's continue. Before this, we have 2.2 confidence interval for one population mean. So now we have 2.3 confidence interval for the difference between two population mean. So now you have two mu1 and mu2. So in this 2.3, we will estimate confidence interval for the difference between two mu of independent samples and the other one between two mu of dependent sample. Okay, so before this you have confidence interval 1 mu. So where in 1 mu you have to, for example, you have a population here and you want to estimate this mu. So what you do is you take a sample and then you estimate this mu using this x bar and using confidence interval. So now, in estimating the mu, you have to construct the confidence interval. You will have three cases here when the sigma square is known. Sigma square is known, you have to use the first formula. When the sigma square is unknown, it's not given, you have to consider the sample size, n greater than 30, you have to use z. And when the sigma square is unknown, n less than 30, you have to use t. This one for 2.2. So now you have confidence interval between two mu, means that mu1 minus mu2. For example, you have population 1 mu1 and then you have population 2 mu2. So now you want to estimate the difference between these two mu. Okay, no, we will use confidence interval mu1 minus mu2. Okay, so confidence interval, the difference between two mu. So recall back, we have confidence interval for 1 mu. So confidence interval 1 mu. So now we have confidence interval between two mu, mu1 and mu2. So the first cases is independent. So let's look at the first cases, independent. So independent sample means that independent sample are measurements made on two different set of items which samples are taken independently. Sample A and sample B is independent. It's not related. For example, you have a sample from UTM and you have sample from UMP. So these two samples are not related. So we call that is independent. So sometimes the sample size can be similar and sometimes can be different. So it depends on the sample size, right? And it came from the different subject. It must be not related. Okay. So if independent sample, we will use mu1 minus mu2. So what are the formula to construct confidence interval independent cases? So confidence interval independent cases is mu1 minus mu2. So first, what you need to consider is there any sigma given? So because you have two samples, so you will have two sigma. Is there any sigma given? If there is any sigma given in the equation, you have to use the first formula. Okay, then if sigma square is not given, what you have to consider? You have to consider, look at the equation, they were stated both population variance are equal or both population variance are not equal. Okay, assuming that both population variance are not equal. Okay, assuming that both population variance are not same. Okay, are not same. You have to look at the sample size. If sample size greater than 30, both sample size greater than 30, use the second formula. If the sample size both is less than 30, use the third formula, and notice here you have T alpha over 2 nu, where the formula to find nu is here. It's very long, and don't forget to round down the value of nu. For example, you get the nu after you calculate is 2.7112. So round it down, it will become nu is equals to 2. Round it down. Okay, next, when they said that assuming both population variance are equal, okay, both population variance are same or equal or similar, you have to look at this one. These cases, look at the sample size. If both sample size greater than 30, you will have the fourth formula. If sample size both is less than 30, you will have the fifth formula. So notice here, for the equal variance, you will have SP, pooled standard deviation. So where the SP is equals to this formula. Okay, so you have to look at the question very careful. So you have to choose which formula you want to use to construct the confidence interval. Okay, so these are the keyword. If the question stated both population variance are similar, use either formula number 4 or formula number 5. If the question said that assuming both population variance are not similar, are not equal, are unequal, you have to consider formula number 2 or formula number 3. If they give you sigma, you have straight away using formula number 1. Okay, let's look at the example. Alright guys, let's do example 2.6. Read the question carefully. Two chemicals companies, company A and company B. So you have A and B, supply a raw material where the most important element in this material is the concentration. The standard deviation of concentration produced by both companies are known as 5.81 and 4.7 respectively. Okay, you have company A and you have company B. Alright, you have 5.8 and 4.7. The mean of concentration in a random sample of 10 batches produced by company A. So company A is 10, is 90.25 gram. Okay. While for company B, the mean of concentration in a random sample of 15 batches is 87.54 grams per liter. Consider the random variable concentration is normally distributed. Construct a 96%, so confidence level 96%, confidence interval for the difference of the population mean. So the difference of population mean, mu A minus mu B, difference of the concentration produced by both companies. Give an interpretation for the parameter estimate. So you have all this information. So are known as is population. Okay, so we have all the figures now. So what is the notation? What is the notation for 5.8 and 4.7? Population, right? So population standard deviation is sigma. Sigma for A is 5.8, sigma for B is 4.7. Okay, and then random sample of 10. So this one is sample size, and then mean x bar. Why x bar? Because they take sample 10 and then they calculate the mean. So you have all this information. You want to find confidence interval, the difference between company A and company B. So what is the formula that you want to use? We have the 5 formulas. So let's look at the formula. Which formula you want to use to construct the confidence interval difference between population mean company A and population mean company B? Okay, let's look at the formula. So, can we use formula number 1? Is there any sigma or sigma square given? Yes, we have the sigma and sigma square. Okay, from sigma we can get the sigma square. So straight away using first formula because sigma is given. So what is the first formula? So we write back the first formula. X bar A minus X bar B plus minus Z alpha over 2 square root sigma A square over NA plus sigma B square over NB. Okay, this is the formula. So check one by one. Do we have X bar A? Yes, 90.25. Do we have X bar B? Yes, 87.54. Do we have sigma A square? Yes, here. Do you have sigma B square? Yes, 5.7 square. And A is 10 and B is 15. Now, you don't know this value. So, like the example in topic 2.2, you can find Z in your stat table. So I hope from now on you can know how to find Z table in your stat table. So confidence level 96%. So alpha is 0.04. So alpha divided by 2 you will get 0.02. So Z 0.02. Look at your stat table. Look at carefully. You will get 2.0537. So now what you have to do is substitute all into this formula. Okay. Confidence interval. Big one. X bar here is 90.25. minus 87.54 plus minus 2.0537 times square root 5.8 square over 10 plus 4.7 square over 15. Okay, then you put it into your calculator carefully. You will get the answer is lower limit negative 1.8120 and the upper limit is 7.2320. Don't forget the unit gram per liter. Okay. So how do we interpret if we have negative here? So kita interpret macam ni. We are 96% confident that the difference of population mean between company A and company B is between 1.8120 gram per liter more by company B to 7.2320 gram per liter more by company A compared to each other. Okay, so that's all for example 2.6. Alright, example 2.7. A biotechnology company produces a therapeutic drug which concentration is normally distributed. Two new methods of producing this drug has been proposed, and the method that produce more drugs will be chosen by the management. The company chose a sample size of 15 from each method and obtain the following data in grams per liter. So you know that here is method X, method Y. So sample size of 15 from each, so here is N, 15, 15. Okay, mean. So mean, they take a sample, so what is X bar, this one is S because they already take the sample. Right, but assuming the population variance for both methods are equal, so population variance for both methods are equal means that here sigma x square is equals to sigma y square. Construct a 99% confidence interval on the difference between means of the concentration by method Y and method X. So method Y come first. So method Y come first and then method X. So now they ask you to construct a confidence interval, the difference between X and Y. So mu Y minus mu X. Why Y minus X? Because they mention Y and then X. So mu Y minus mu X. So confidence level 99%. So which formula you want to use? Can we use formula number 1? Can we use formula number 1? Cannot, because they did not give you any sigma value. They just give you N, X bar and S. They didn't give you sigma, but they did mention here sigma square X equals to sigma square Y. So sigma square X, sigma square Y equals to sigma square X. So you don't know the sigma, but you have to consider here. Assuming both population variance are equal. So this one you cannot use because unequal. This one is also unequal. Now you have this choice. Formula number 4 or formula number 5. So look at the sample size given. Sample size is 15. So less than 30. So because of sample size less than 30, we will use this formula. Okay, so the formula you will have here x bar 1 minus x bar 2 plus minus t alpha over 2 nu sp square root 1 over n1 plus 1 over n2. So we have the formula for nu n1 plus n2 minus 2, and we also have the formula for sp here. Okay, so what is the formula? The formula is x bar y minus x bar x. Okay, then plus minus t alpha over 2 nu sp square root 1 over ny plus 1 over nx. Check one by one. We have x bar y, we have x bar x. We have the ny, we have the nx. Now you have to find the sp and the t alpha over 2 nu. So from confidence level 99%, so alpha is 0.01. So alpha over 2 is 0.005. Okay, so the nu is equals to ny plus nx minus 2. So 15 plus 15 minus 2, you will get 28, the nu. So t 0.005, nu is 28. Look at your stat table, you will get 2.7633. So now done for the t. Now find sp. The formula for sp is square root ny minus 1 times sy square plus nx minus 1 sx square divided by ny plus nx minus 2. Okay, you substitute all the values. Our n is 15 minus 1 times 0 times 1 square plus 15 minus 1 times 0.05 square divided by 15 plus 15 minus 2 square root. Put into your calculator. Calculate it carefully. You will get 0.7080. Okay, now you have the SP, you have the T. Substitute all into this formula. Okay, so the confidence interval, you will get here x bar y is 17.41 minus x bar 2 is 16.22 plus minus 2.7633 times 0.7080 times square root 1 over 15 plus 1 over 15. Okay, you put into your calculator and then you will get the answer. Lower boundary 0.4756 and the upper boundary 1.9044 gram per liter. Okay, and then don't forget to interpret. We are 99% confident that the difference of population mean between method Y and X lies between 0.4756 and 1.9044 gram per liter. Okay, the keyword here is you have to look at the question carefully. Choose which formula that you want to use. Okay. Okay, now let's try to do the exercise. You can try first and then you can compare your answer with mine here. Alright, the mean of sleep time for 50 students are 7 hours with standard deviation of 1 hour. So you will have IPTS, the mean of sleep time. So you will have the N here for 50 students. The X bar is 7 with standard deviation 1. The mean of sleep time for 60 IPTA students, then you will have IPTA is 6 hours. So IPTA is 60 students, 6 hours, and standard deviation is 0.7 hour. Assume that the sleep time IPTS and IPTA are normally distributed. Find the confidence interval for the difference population mean sleep time between IPTS and IPTA. So mu IPTS minus mu IPTA. Now I will assume IPTS is 1, IPTA is 2. So mu 1 minus mu 2. So which formula you want to use? First, you have to assume the population variance are same. Means that sigma 1 square equals to sigma 2 square. So for A, sigma 1 square equals to sigma 2 square. So which formula you want to use? We have N50. Okay, so which formula? You cannot use this one because we don't have the value of sigma. So we said that sigma 1 square is equals to sigma 2 square. So equal, so this one cannot use because of unequal. So we have two choices here. N is equals to 50 and 60. So both is more than 30. So this one cannot use. So you have to use this formula. Okay. X bar 1 minus X bar 2 plus minus Z alpha over 2 SP times 1 over N1 plus 1 over N2. Okay, so let's go back to the equation. So we will have the confidence interval X bar 1 minus X bar 2 plus minus Z alpha over 2 times SP times 1 over N1 plus 1 over N2. So check one by one. You have the X bar 1. Yes, 7. X bar 2 is 6. So you have the N1 50 and 2 is 60. Now Z alpha over 2 and SP you have to find. Okay, confidence level is 99%. So alpha is 0.01. Alright, so alpha over 2 is 0.005. Z 0.005 is equals to 2.5758. Then calculate the SP. SP is equals to square root 50 minus 1 times 1 square plus 60 minus 1 times 0.7 square over 50 plus 60 minus 2. So here you will get 0.8493. Make sure you calculate it correctly. Right now we have the SP, we have the Z alpha over 2. Substitute all into the formula. So I will put here. So confidence interval is X bar 1 is 7 minus 6 plus minus 2.5758 times SP is 0.8493 times 1 over 50 plus 1 over 60. Okay, so now here you calculate, you will get the lower boundary is 0.5811 and the upper boundary is 1.4189 hours. Okay, don't forget to interpret. We are 99% confident that the population mean difference between IPTS and IPTA lies between 0.58 and 1.42 hours. Okay, so for B, assume the population variance are different. So now I leave it to you to do 1B and please submit the 1B exercise through GC. So exercise number 2. For exercise number 2, two groups of students are given a problem solving test and test marks are compared. The data are as follows. So this one for mathematics major, this one is for computer science majors. Find the 98% confidence interval. So confidence level 98%. Confidence interval for the different population mean of test mark between the two group of students. So we assume that major mathematics is 1, computer science is 2. So mu 1 minus mu 2. assume the variance population test mark are not same. So the keyword here, variance are not same. So sigma 1 square not equals to sigma 2 square. Okay, so we have the n, we have the x bar, we have the s. We have the n, x bar and the s. So which formula that you want to use? So let's look back at the formula here. They have given n, x bar and s. So they did not give you any sigma value. So you cannot use this formula. Okay, so you want to use equal or unequal. Let's look back here. You have assuming both population variance are unequal, are not the same. So you cannot use this one. So you can use either number 2 or number 3. Consider the sample size. Sample size is 15 and 14. So sample size both is less than 30. Use formula number 3. Okay, so formula number 3, you will have x bar 1 minus x bar 2 plus minus t alpha over 2 nu times square root s1 square plus s2 square over n1 over n2. Okay, alright. So now, did you notice how to find the nu here? The nu here is no longer n1 plus n2 minus 2. The nu here have the formula. So this is the formula to find the nu. It's a little bit tedious here. Okay, so let's do it together. The formula is x bar 1 minus x bar 2 plus minus t alpha over 2 nu square root s1 square over n1 plus s2 square over n2. So we have the x bar 1, we have the x bar 2, we have n1, we have n2, we have the s. Now we don't have this one. Okay, so confidence level 98%, alpha is 0.02. So alpha over 2 is 0.01. Okay, so to find the nu, you have to use this formula. Okay, this formula. So the formula is s1 square over n1 plus s2 square over n2. And then you square it, you divide by s1 square over n1 square it plus s2 square over n2 square. Here divide by n1 minus 1, here divide by n2 minus 1. Okay, you have to do it very careful, right? So substitute all the values. S1 is 3.3 square divided by 15 plus 2.8 square divided by 14. You square it and then you divide. S1 is 3.3 square divided by 15 over N1 is 15 minus 1 plus S2 is 2.8 square over 14 square divided by 14 minus 1. Okay, you have to do it very careful here. So my answer here is 26.7729. So this value you have to round down. So round down, the nu will become 26. Okay, so nu 26. T 0.01 nu is 26 is equals to 2.4786. Alright, so you have the T now. and then substitute all into the formula. Okay, substitute all into the formula. So the confidence interval is equals to our x bar 1 is 83.6 minus x bar 2 is 79.2 plus minus 2.4786 times the formula S1 square over N1. So S1 is 3.3 square over 15 plus 2.8 square over 14 square root. Okay, so you solve it, you will get the lower boundary is 1.5892 and the upper boundary is 7.2108. Okay, so don't forget you have to interpret. So we are 98% confident that the difference between population mean of marks, math major and science major lies between 1.5892 and 7.2108. Alright, number 3. The burning rates of two different solid fuel propellants used in Aircrew escape system are being studied. It is known that both propellants are normally distributed and have the same population variance. So these are the keywords. The same population variance mean that sigma squared equals to sigma 2 square. Two random samples of 26 specimens for each propellant are tested. So it means that the N is same to 26 each. The sample mean. So here is X bar and standard deviation are summarized as in table below. Construct 90% confidence interval. So 90% confidence interval on the difference in population mean for propellant 2 and propellant 1. 2 come first. Okay, so here they ask you for confidence interval mu2 minus mu1. Okay, not 1 minus 2, 2 minus 1. Right, and then so here you have the and you have the equal here and confidence level 90%. So which formula you want to use? Let's look at the formula. Can we use formula number 1? Cannot, because we don't have the sigma values. So you want to use equal or unequal variance. So look at here, equal. So equal, so you cannot use this one, equal, or either number 4 or number 5. Sample size is 26. So 26 is less than 30. Okay, so you have to use this formula. Alright, so the formula is x bar 1 minus x bar 2 plus minus t alpha over 2 nu sp times 1 over n1 plus 1 over n2. So where the nu is equals to n1 plus n2 minus 2. And the SP is n1 minus 1 s1 square plus n2 minus 1 s2 square over n1 plus n2 minus 2. Okay, so these are the formula. Now I want to put propellant 1 and propellant 2. Okay, so now you have to construct confidence interval mu propellant 2 minus mu propellant 1. Okay, so formula is x bar propellant 2 minus x bar propellant 1 plus minus T alpha over 2 nu SP times 1 over n propellant 2 plus 1 over n propellant 1. Okay, close it. So look at one by one. We have x bar, we have the n. So we don't have T alpha over 2 nu, we don't have the SP. So confidence level 90%, alpha is 0.1. So alpha over 2 is 0.05. Nu is equals to n propellant 2 plus n propellant 1 minus 2. 26 plus 26 minus 2, you will get 26 plus 26 minus 2, 50. Okay, so T 0.05 nu is 50 is equals to 1.6759. So now calculate the SP. So you calculate the SP. My SP, I got SP is equals to 2.9159. Okay, substitute all into the formula. X bar P2 is 24.412 minus X bar P1 18.312 plus minus 1.6759 times SP 2.9159 times 1 over n propellant 2 26 plus 1 over 26. So you solve it, you will get your lower boundary is, and the upper boundary centimeter per second. Okay, and then you don't forget to interpret. Lies between 4.7447 and 7.4553 centimeter per second. Okay, done for the confidence interval independent cases.